All right, so the first question says, a survey conducted among 100 people about the amount that they paid on a monthly basis for their cell phone contracts. The person carrying out the survey calculated the estimated mean to be 309 Rand per month. I'll come back to what that means in a second. Unfortunately, he lost some of the data thereafter. The partial results are shown in the frequency table below. Okay, so there's a couple pieces of information that we need to just be mindful of the fact that we do actually have here. So first thing is we were told that it was a survey amongst 100 people. So whatever happens, if I were to go and add my frequency column, I know that I must get 100. Okay, that's what that piece of information means. The next piece of information that we were told is the fact that the estimated mean was 309 Rand. Now, this is taking us back to probably, like our grade 10 stats. We might have done a little bit of this in grade 11, but pretty much grade 10 stats. So what is estimated mean? I actually don't want to do that there. No space. Okay, so estimated mean. I'm just going to write a little note up at the top here. Your estimated mean, and please don't panic by the formula, I'm going to explain it all now in a second, is when you have the sum of the midpoints of your intervals times your frequency divided by your total number of data points. So that's what your estimated mean is. Now, this needs to take us back to, like I say, probably grade 10, where we worked out the estimated mean of grouped data. So I'm just going to extend and add to my table here. Right, so estimated mean, we don't know the individual data points in each of my intervals. So what I mean by that is, in this first interval, I know that there are 7 data points between 0 and 100. I have no idea what they are. I don't know if it's 2, 5, 5, 7, 8, 9, 9. I don't know if they're all 8s. I don't know if there's 92, 58. I have no idea what the data points are. Absolutely no idea. And so unfortunately, what that means is if we want to estimate the mean of my data set, it is exactly that. It's an estimate. Because I don't know what my data points are, I'm going to have to make an educated assumption in order to go work out my estimated mean. My educated assumption is based on statistics. So what I want you to remember is that we have got measures of spread, measures of dispersion, we've got measures of central tendency. Measures of central tendency is the measure of the average of your data set. You know, kind of more or less, what is the average data point, the average value? What can I sort of take away as an assumption of the value of my data set? One of those measures of central tendency is your median. So remember, your median is your middlemost point of an ordered data set. And we can use that fact that the median represents an average, a more or less decent picture of my data in the calculation of my estimated mean. What that means is I need to find the midpoint of each of my intervals. Remember, midpoint, median, they represent the same thing. Midpoint is the middle point of my interval. It would be the median, the middle point of 0 to 100. And what I'm essentially doing is I'm then assuming that all of the data points in that interval are that midpoint value. So the midpoint between 0 and 100 is 50. And what I'm essentially now going to do is I'm going to say, okay, cool. All 7 of those data points are 50. They aren't. The likelihood of them all being 50 is very, very small. However, because we don't know what they are, we need to make that assumption. So we're saying 50 gives us a good average of that first interval. So I'm going to estimate that they're all 50. And we do the same thing for all of our intervals. So the midpoint of the next one is 150, then 250, then 350, and so on. What you should see with your midpoints is that it does form a pattern. So in this case, I'm adding 100 each time. If you're not getting a pattern, you've probably done something wrong. So just double check that. Okay. Once we have that midpoint, according to my formula, I would need to times my midpoint by my frequency so that I can add them all together. So I often like to have an extra column in here, and obviously I don't show the whole screen. Why on earth would I make my life easy? And I like to have an extra column that is basically midpoint times frequency. So midpoint times frequency. And I'm going to do exactly that. Now, bear in mind that because they told us that it was the partial results, I don't know some of the values. I don't know A and I don't know B. That will become important a little later on. But for now, let's just go find the products. So the first one would be 7 times 50, which gives us 350. The next one would be 12 times 150, which gives us 1,800. 250 times A, which is 250A. We don't know A, so we just leave it like that. 35 times 350 is 12,250. 450 times B is just 450B. And then 6 times 550 is 3,300. And so now when I want to go and find my estimated mean, I would add all of those products together and I would divide it by the 100 people in my survey. Okay, I'm not going to do that because we're actually going to do that in a second or two. So let's actually go and read these questions, see what we need to do, but that is what estimated mean is, just as a quick refresher of how you go and calculate it. First question says, how many people paid 200 Rand or less on their monthly cell phone contracts? Now, really importantly, we're saying 200 Rand or less. There's the 200 Rand, and we're including 200 Rand because it says 200 or less. So it can be 200 or it could be less than. And what we need to realize is that these first two intervals, the first two intervals is 200 Rand or less. The first interval is between 0 and 100 Rand. The second interval is between 100 and 200. So all of the people in the first two are 200 Rand or less. So that gives us 19 people who spent 200 Rand or less on their cell phone contract. Nice and easy, I just read off the information. This is now where we're going to do a little bit more. So question B says, use the information above to show that A equals 24 and B equals 16. Now, before we get into it, this question is what I call a show that or a prove that question. If your question starts with show that or has somewhere that you need to show that or prove that, what you need to know is that you cannot use the values you've been given in your working out. Only place in your working out where I should see A equals 24 and B equals 16 is in your final answer when you've actually gone and proved that or shown that those values are true. This is a question that we often ask in functions as well. So oftentimes when we give you like an equation of a function and we leave the A and the B or the P and the Q or whatever, and we leave those values and we say, show that A equals whatever, B equals whatever, C equals whatever. You cannot just substitute them in and say, okay, cool, well, that does give me the given turning point or the given x-intercepts. You actually need to go and use the information you've already been given to go and show that the values are true. So what I mean by that is, we've been asked to show that these values are what they are. What you may not do is say, okay, cool. Well, I know if I were to add all the frequencies together, I must get 100. There was 100 people in the survey. So I'm just going to assume let's assume A is 24 and B is equal to 16. 7 plus 12 plus 24 plus 35 plus 16 plus 6. Well, if I add that all up, I do get 100. So surely they must be true. No, you may not do that. Why? You've assumed that the values I've given you are true. That's not the case. How do you know that it wasn't 20 and 20 or 30 and 10? We just know that they should add up to 40, but I've got no idea what two numbers I'm adding together. You have assumed that 24 and 16 is correct. So what you actually need to go and do is you need to go and use all of the other information that you've been given and do some sort of calculation to go and work out what A and B are. So if we go back to what we were given that N is 100 and we were given the estimated mean. Those are the two important pieces of information that we were given. Now, because you're solving for two unknowns, it's potentially possible that you're going to end up with a simultaneous. In this case, you are. But let's go and have a see what's happening. Sorry, I thought I heard someone outside. Okay. So we do know that if we add up all our frequencies, we should get 100. But I'm not going to assume what A and B are. So 7 plus 12 plus A plus 35 plus B plus 6 must give me 100. I know that's true. Don't know what A and B are, but I know that's a true fact. If you add 7 plus 12 plus 35 plus 6, you get 40. So we get that A plus B plus 40 is equal to 100. You don't get 40, you get 60. Do apologize. And so if you want to neaten that up a bit, A plus B is equal to 40. Okay, so we've got that information. The next bit of information that we were told is our estimated mean. Now, because we've already done a whole bunch of calculations, this does make my life a little bit easier. But we know that if we go and add up those midpoint times frequencies, I must get a certain value that I then divide by 100 to get my estimated mean. Now, we know what the estimated mean is. We know it's 309. And so if I go add up 350 plus 1,800 plus 250A plus 12,250 plus 450B plus 3,300 and divide that all by 100, I must get my estimated mean. Right, so us doing that working out earlier helped us. I'm going to neaten things up, but get rid of the fraction, so times both sides by 100. 30,900 is equal to, if you add up all of the constants in your fraction, you get 17,700 plus the 250A plus the 450B. I'm going to bring that 17,700 over, so subtract, giving me 13,200 is equal to my 250A plus 450B. You could divide all of that by 10 if you want, but I'm just going to stop there for a second. And what you should notice is that just by using the given information, you have set up two equations in terms of A and B. Now, obviously, I don't leave myself enough space when I do this. So we've got two equations now. Equation 1 and equation 2. This should sort of indicate to you that you're going to now work with simultaneous equations. Alrighty, now the easier of these two equations is the first, so I'm going to isolate a variable here. It makes no difference if you isolate A or B, they both have a coefficient of 1. It's easy. I'm just going to go A is equal to 40 minus B. Now, we know that what that means is I can now take that value for A and I can substitute it into my second equation in place of A. So that means I've now got the 13,200 is equal to 250A, so 40 minus B, plus 450B. Now you've got an equation in terms of B and you can solve for B. Distribute that 250 into your bracket, so you get 13,200 is equal to 10,000 minus 250B, and this is then nice and easy to solve. Bring the 10,000 over, you get 13,200. Negative 250 plus 450 is 200B. divide both sides by 200, you get that b is equal to 16. That is my final answer. That's the only time I should see b equals 16. You've actually gone and solved for it. Then obviously we need to get a, but we know a is equal to 40 minus b. So we just substitute in our value for b that we just found. 40 minus 16 is equal to 24. So I've proven that a is 24, b is 16. And at no point did I ever use or assume that those values were true. I actually went and calculated it. Right, so in this case, just so that you're aware of mark allocations, because show that questions, you don't get marks for your final answer of a equals 24, b equals 16. So you're going to get a mark for setting up your equation using your frequency of 100. Let's do that a bit better. Woo, sorry. So understanding that you should add all your frequency amounts to get 100. You're going to get a mark for setting up an equation using your estimated mean. You're going to get a mark for isolating one of your variables, for substituting into the equation, and then just general working out thereafter. Because it will show that the values are 24 and 16, you do not get a mark for saying a equals 24 and b equals 16, because technically I'm telling you they are. I just want you to prove to me that that's correct. So you don't get a mark there, but you pretty much all of your working out is all of your marks. Okay, so we could have been more generous with marks, absolutely, but this is a slightly more complex question, so we don't generally allocate a lot of marks for a single complex question because that's mean. Okay, so just let you know where those 5 marks would go, that's where it would go. Okay, but if for whatever reason you're not able to prove that the values are what they are, in your subsequent questions, assume that A is 24 and B is 16. So if you weren't able to answer question B, for question C, D, E, F, however long it goes on for, assume that those values are true. So we do now know that A is 24 and B is 16. And so now I have those frequency values in my table. So question C says, write down the modal class for the data. So have a look. Tell me, you can unmute, you can put in the chat. What is the modal class for this data set? Modal class, modal interval, same thing. But I want you to tell me which one is the modal interval or class. Anyone? Modal interval? Okay, well, we would look for the highest frequency. The highest frequency here is 35, so our modal interval is 300 to 400. So we're then asked to draw a cumulative frequency graph or an ogive. Now remember, for you to draw an ogive, you need your cumulative frequency and you need to know the endpoints of your intervals. Obviously we have that, but we need our cumulative frequency still. So let's just go and work that out. Cumulative frequency is you adding up your frequency amounts, nothing more than that. So this last column I'm going to use for cumulative frequency. First one is always just the first frequency. So in this case, 7. 7 plus 12 is 19. 19 plus, and we know A is 24, so assume it. plus 24 is 43, plus 35 is 78. Again, we now know that B is 16, so work with 16. 78 plus 16 is 94. 94 plus 6 is 100. So we have our cumulative frequencies. So remember, like I said, excuse me, cumulative frequency is your Y value, your X value, are your endpoints of each of your intervals. So the 100, 200, blah, 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 blah. And remember, you always ground your ogive or start your ogive at the lower interval and 0. So in this case, you would ground it at 0, 0. All right, I'm just going to make that a touch smaller so that I can draw. Now, paper 2, you get an answer book, and so you will get your set of axes in your answer book for you to be able to draw your ogive. I have said this to you before. Generally, you're going to be asked to draw an ogive. Okay, so do you know how to do it? So we grounded 0, 0. Then we plot. So it was 107. These blocks are going up in 2. So 2, 6, 7, 219. And so we keep going. I'm not going to talk in your ear. I'm just going to keep plotting. Remember, it's cumulative frequency that you're plotting here. Your last point should also always be in terms of your cumulative frequency, your total number of people, or total number of data points. Okay, so there's all my points. You now join them. Remember, it is not with a line, it is with a curve. So I should not see any ruled lines. I'll do best here. But there you go. That's sort of your ogive. It's good enough. In terms of your ogive marks, because it's a 4 marker, so you need to, again, know how to draw a graph. You get a mark for where it's grounded. You get a mark for its endpoint. I should obviously keep going. Generally, you get a mark for its shape, and then you get a mark for the accuracy of your point plotting for each of your coordinates. It might only be 3 marks. So you might get a start point, an end point, and a shape mark. But, excuse me, 3 or 4 is generally your ogive mark allocation. So question E says, determine how many people paid more than 420 Rand per month for their cell phone contracts. Okay, so firstly, you have been given a Rand amount. So what that means is you're looking on your x-axis. So we're going to go to 420. This is going up in 10. So there's 420. And you're going to draw your line until you meet your ogive. Remember, obviously with a ruler. Hit my ogive, and then I go across. Now that's halfway between 80 and 82. So that's at about 81. So what this is telling me, and we need to be very careful of what that 81 actually means, is that 81 people, and remember, this is cumulative frequency. So this is including or adding up the frequencies of all of these prior intervals. So this is actually saying that 81 people paid 420 Rand or less. The question asked, how many people paid more than 420 Rand? So now I need to go and just think about what that means. So more than 420. That means I'm going to look at, or I'm wanting these people on the upper end of my ogive. So if we have a look here, I want to know how many people is represented by this upper portion of my ogive. Because there were 100 people that took part in the survey, and we know 81 paid 420 Rand or less. If we subtract those two amounts, we get that it was 19 people who paid more than 420 Rand. Now, again, this would be considered by some students as a hard question, but it isn't. If you read your questions carefully, and you make sure that you are actually answering the question, you're going to be fine. So this is just a 2 marker. You're going to get a mark for the 81, so do actually reading off the value, but then you're going to get a mark for understanding that you needed to subtract to get the more than. And this is just based on what cumulative frequency is. It's adding up prior interval frequencies, so everything below. If you want above, you would need to find the difference. All right, so let's take a screenshot of that. I'll scroll down so you can get the rest. In grade 12, please remember, if you've got questions, just ask. If you think of any other questions about maths, doesn't have to do with stats, ask. I'll take a little break from stats and then come back. But please do ask questions if you have. Okay, last little bit. Take a screenshot. That's now your complete ogive and the last question. And then let's have a look at example 2. Okay, so guys, generally in your paper 2, you've got 2 questions on stats. It's question 1 and question 2. Generally, you're going to have grade 11 level stats, ogives, mean, median, nice, easy stuff. And then in your next question, you will have grade 12, standard deviation, correlation, coefficients, line of least squares regression, least squares regression line rather, so A and B, all of those things that we spoke about on Monday come into your second question. So you'll have a grade 11 level question and you'll have a grade 12 level question. Just accept it, it is going to be there. That's how it is. Right, so if we have a look at example 2, this is now sort of a grade 12 level question. This was from a recent past paper. I can't remember off the top of my head which one, but it was a relatively recent one. Should have written it down, I didn't, but yeah. The matric class of a certain high school had to vote for the chairperson of the RCL. The scatter plot below shows the IQ of the 10 learners who received the most votes and the number of votes that they received. Now again, guys, just look at your scatter plot before you answer any questions. There's no trend there. The dots are kind of scattered. So if we were to go and work out a correlation coefficient, it would probably be one that is low and unreliable or have a weak correlation. Right, it then goes on to say before the election, the popularity of each of these 10 learners was established in a popularity score of 100 assigned to each. The popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below. Basically, what that's saying is the 10 learners of the scatter plot are the 10 learners who got the popularity scores that we've now shown in this table. So you've got a table, you've got a scatter plot, they've been nice, they've labeled the X and the Y. The second you see that, you know, you're probably going to work out least squares regression line, correlation coefficient, etc., etc. Right, so if we have a look at our first question, it says calculate the mean number of votes that these learners received. Now, you can do this in 2 different ways. It's completely up to you. Option number 1 is you can work out the mean old school, and you can just add all those values together, 9 plus 22 plus 10 plus 21, blah, 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 divided by the 10 and get your mean number of votes. Completely up to you. However, you know that you are likely going to be asked correlation coefficient, least squares regression line, all of those things. So my advice is just put your data into your calculator straight off the bat. Headphones are done. Just change them. Okay. So my advice is immediately type this into your calculator. We know, because we did it on Monday, how to go and work out the average of one of those variables, so the X or the Y. We know how to do that. And so rather just have the data already put in for yourself to then go do a whole bunch of things. So I'm going to give you 2 minutes. No, I'm not going to give you 2 minutes. I'm going to give you like 60 seconds.
quickly type that data into your calculator so that you can do it with me. And then we will answer that question. Right, so all my data is in. Remember, we now want the mean number of votes. Number of votes is Y. So AC, I can now do what I need to do. Shift 1, I'm looking at average, so option 4, and I want the average of Y, so I'm going to select number 5. So average number of votes, 15.5. That's it. So here, oops, it would help if I selected a pen. 15.5. Obviously, can't get half a vote, so about 16 votes. Sorry. My advice, guys, is write down the decimal. If the context then sort of suggests that you should round off, then round off, but write down the decimal first and then go and round off. Generally, we are going to give you the mark if the context suggests it should be discrete, but rather be safe and write down your decimal. Alrighty, next question says the standard deviation of the number of votes that these 10 learners received. So grab your calculator again. You want the standard deviation of the number of votes. So we want sigma of Y. Again, if we now go shift 1, still to do with variance, option 4, and you look at option 6, that is sigma of Y, the standard deviation of Y. So we click option 6, and we get that the standard deviation is 4.59. Again, if it doesn't say, you round off to 2 decimal places, with sigma of Y, 4.59. So what that's saying is that there is a spread or a distance, for lack of a better description, of 4.59 votes either side of your mean of 1 standard deviation, and then 2 standard deviations, and so on. Question B then says, the learners who received fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? So really importantly, again, this goes back to what I was saying from question 1, read your questions carefully. How many learners were invited? The information says the number of learners, or the learners who received fewer than 1 standard deviation, were not invited. All right, so first things first is we want to figure out what is 1 standard deviation below the mean. Now, again, use your decimal value. So 15.5 minus 4.59, because that will be 1 standard deviation below. If you go and subtract that, you get 10.91. So essentially what that's saying is if you got 10,91 votes or below, you were not invited for an interview. So everyone above 10,91 was invited for an interview. So if we now go back to our table, we want 10,91 votes or more. So 9, obviously not. 22, yeah, they're above the 10,91. 10, no, they've just missed it. 21, 11, 15, all the rest of them. So of the 10 learners, 8 of them were invited for an interview, 2 were below 1 standard deviation, and so were not invited. And again, this is not a hard question, but if we don't read it carefully and read it properly, then we make silly mistakes. So only 8 of the 10 learners were interviewed. Right, question C asks us to determine the equation of the least squares regression line. My data's in, so I can go do that. Click AC, shift 1, and we're now looking at regression. So we select option 5. We need A and we need B, because remember the equation of your least squares regression line. Let's try that again. Is y is equal to A plus bx. So we need those 2 variables. Right, so it was shift 1, 5. I'm going to get A first. So option 1, 1,77. And then I want option B. So again, AC shift 1, option 5, regression, B is to 0,22. The equation of my least squares regression line, y is equal to 1,77 plus 0,22x. That's it. Right, now that you have that, remember you can start making predictions. So question E is saying predict the number of votes that a learner with a popularity score of 72 will receive. So remember, popularity score was X, number of votes is Y. So I'm going to give you 2 minutes. Use the least squares regression line equation that we've just discovered to work out how many votes a student with a popularity of 72 will get. Right, so you're working that out for me. You can put your answers in the chat. Right, little concerned that we're taking so long to substitute, so I'm just gonna go ahead and do it because either we're not focused or we're struggling. So y is equal to the 1,77 plus 0,2x. All you're doing is substituting into your equation. So we substitute in 72 in place of x, and you can get the number of votes. So that gives you 17,61. Again, number of votes, so you can round that off to about 18 votes. Right, E says, using the scatter plot and table above, provide a reason why. In the first one, IQ is not a good indicator of the number of votes that a learner could receive. So if we scroll back up, the scatter plot dealt with the IQ, and I've actually already explained this. Because these points are so scattered, and we can see that there clearly is a very weak correlation, it is not a good indicator of votes received by a student. It doesn't allow for an accurate prediction. So here we would say our points are scattered, indicating a weak correlation. Well, that's actually all you need to say, really. If you wanted to go further, you could say, hence, you can't make a reliable prediction. Right. The second question says, provide a reason why the prediction in D is reliable. So D is bad boy over here. We've just made the prediction of 72. Now, this was all using my least squares regression line. So what I'm going to have to do there is I'm going to have to determine what my correlation coefficient is. Again, everything's already on your calculator. You just go type in shift 1, 5, blah, blah, blah. So shift 1 or AC shift 1 regression. And now we want the R value, the correlation coefficient, 0,98. That is a very, very strong positive correlation. And so what that means is any prediction that we make, or most predictions we make, I should say, are going to be reliable. Right, so just always bear in mind what it is you're looking at. Scatter plot, how close together or how scattered your points are, tells you about their correlation. If you look at your least squares regression line, determining the value of the correlation coefficient R tells you about your correlation, because it's a correlation coefficient. Okay, but let's take a screenshot. I'm just going to make this a touch smaller. We can get a little bit more in. All right, so there's information in A. Okay, and there is B, C, D, and E. Right. Okay, now, as much as we do often ask you to draw ogives, just remember we can always give you an ogive and expect some sort of analysis from it. So if we look at example 3, a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel for a particular month. Data is represented in the ogive or cumulative frequency graph below. There it is, sorted. Now guys, what I want you to bear in mind is that you don't have the table that goes with this. So you now need to think back to what should the table sort of look like in order for me to get these points. Firstly, is that you know your very first interval starts at 5 and goes up to 10, because that would be the lower limit of your interval. So your first interval would be from 5%. Let's just try all of that again. From 5% to 10%. Now I'm going to include 10 because that's the end point of my interval. If you then go to your next interval, that's from 10 to 15. So 10 to up to and including 15. 15 to 20, 20 to 20, etc., etc. Right. That's the first thing. We can see our intervals. Second thing that you should remember is that wherever your ogive ends, that is at the end of your cumulative frequency. So that is at your total number of people, data points, whatever. So wherever this end point is, that's going to give us the information of how many data points do we have. In this case, how many employees. And if you look at the first question, it says, how many employees were employed at the company? We go to the end of our graph and we quite literally just read off that value. So here's the endpoint, read across, nice and easy because it's on the line. There's 60 employees at the company. Right, question B says write down the modal class of the data. Now I have explained this to you before, but just remember that your modal class of your data or your modal interval, that's a bit dark, isn't that? I can't see the writing through that. Your modal class, there we go. Because you don't have a table, you need to use your ogive. You determine the modal class by looking where there is the biggest jump from point to point. Now, the biggest jump from point to point is this section over here. That's the greatest distance between points. And so what that means is that interval between 20 and 25 is my modal class. So between 20 and 25. Remember, 20 would have been included in the interval before at its endpoint. So 25 is included. Question C says, how many employees spend more than 22.5% of their monthly salary on fuel? So we have been given a percentage for amount of fuel spent. Let's do this, 22.5. And so we need to go to percentage of salary spent on fuel, our x-axis. 22.5 is that line over there because that's halfway between 20 and 25. We read up until we hit our ogive. We read across. Now it's sort of halfway between those two lines, so we just kind of make the best. Those lines each count 2, so 32, 34, 36, 38, 40. It's halfway between 34 and 36, so 35 employees. This value here would be 35. Just go back to the question and make sure that you're actually answering it. It says, how many employees spent more than 25%? So remember, everyone below this is 25% or less. We want to know how many employees spent more than. Now, we know that it's 35 employees that spend 25% or less. We know that there's 60 employees in the company. So 60 minus the 35 that spent 22.5 or less would give me 25 employees that spend 25%, 22.5% or more. So always just go back to your question, particularly with questions like this where it's asking, I'm just taking off all my answers now. Particularly questions like this where it asks you how many spend more or less or do more or less, whatever the case is, because 90% of the time, it's going to require you to read off the value exactly like we did, but then it is going to expect you to go and do a subtraction. So make sure you do read your questions carefully and you do actually answer what's been asked of you. Okay, question D, and again, this is now where we start to panic because there's a few more words that we need to read and we don't read properly. An employee spent 2,400 Rand of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. Okay, so oops. We know that whatever his salary is, If we work out 7% of that, we will get 2,400 Rand. Now, this is going back to like your grade 8, grade 7 percentages. So what that means is if I want to work out the salary, I would need to say 2,400 Rand divided by 7%, just basic inverse operations. So you want to divide by 7%, and so X is equal to 34,285 Rand 71 cents. So again, don't panic at the question, read it carefully. 2,400 Rand was spent on fuel, determine the monthly salary. If that 2,400 Rand represents 7% of his salary, 7% of his salary is 2,400 Rand. You use inverse operations to go back and calculate. And then question E says the monthly salaries of these employees remain constant. Let's actually just grab a highlighter here because we're going to have to remember all this information. Okay, so the monthly salaries remain constant. The number of liters of fuel used each month also remains constant. So nothing's changing. They get the same income, they spend the same amount on fuel, or the percentage remains the same. If the fuel price increases from 21 Rand 43 to 22 Rand 79, how much will the above ogive change? So let's just think about what this means. You're earning the same income and you're spending the same percentage of your salary on fuel, but fuel is more expensive. So what that means is that your ogive is going to have to shift to the right. Let's go chat about why that is. I'm going to write it down, shift to the right. Your ogive is going to get steeper. I don't know why I'm going right in there. Right, let's just chat about this. Ogive gets steeper, and let's chat about why. So, same income, same percentage spent on fuel, but the fuel is more expensive. So what that means is that there are going to be more people falling into the lower intervals. Because if you're spending the same percentage, but it's more expensive, you're actually buying less fuel. Okay, so what I mean by that is if you're spending 10% of your salary on fuel, let's say, I don't know, let's say you're in 10,000 Rand and you're spending 1,000 Rand on fuel. Because fuel is more expensive, you do not get as much fuel as you would have gotten before the price increase. And so what that means is that people are actually spending a smaller percentage of their salary on fuel. And so this ogive, I'm not going to draw it very beautifully, is actually going to get steeper and get to 60 a little earlier, or the 60 people a little earlier. Because of the fact that their income hasn't changed, they're spending the same percentage on fuel, but the fuel is more expensive. You can't buy as much of it if you're going to spend the same amount. You can't buy as much fuel. So this question over here is very much an interpretation type question. It's sort of similar to questions that ask you things like, what would happen to the standard deviation if the set of circumstances occurred? What would happen to the mean if the set of circumstances occurred? And so it's understanding how your ogive is actually constructed and what effects it may have depending on the change in your data. All right, let's just make this a tiny bit smaller. So let's take a screenshot of this last example. I'm aware that it is 7:01, so I'm just going to put the screenshots up. And once you got them, you can go and do your quiz. I think most of you are finishing off with exams, but if you're still writing, best of luck. You are